Welcome back to You Revise, where we talk about everything exams. Today we're taking a look at question 42C from the 2016 exam. It says acid rain is a significant issue in many industrialized areas of the world, particularly around power stations using fossil fuels. Legislation has been developed in Australia to minimize the formation of sulfur dioxide, such as from the use of low sulfur fuels in automobiles, which can cause acid rain. Normal rain has a pH of about 5.6. It is slightly acidic because carbon dioxide dissolves into it, forming weak carbonic acid. Rain with a pH less than 4.4 is usually classified as acid rain. Testing was carried out on a rainwater sample taken near a coal-fired power station by titration using sodium hydroxide solution. So a standardization of the sodium hydroxide solution was carried out before it was used in the titration. An anhydrous sodium carbonate primary standard was used to standardize hydrochloric acid solution and subsequently used to standardize sodium hydroxide solution. Sodium carbonate was heated at 110 degrees in a drying oven for 1 hour before 6.08 grams was dissolved in distilled water to make 2 liters of the primary standard. 325 millilitres of hydrochloric acid were titrated and an average titer of 16.4 milliliters was required for the neutralization. An average titer of 21.3 of the standardized 3.76 HCl solution was required to neutralize 25 milliliters of the sodium hydroxide solution. Calculate the concentration of sodium hydroxide solution, and this was worth 3 marks. This question is actually a build-up from what we did in part A. So in part A, I started off telling you that, okay, which is what we're given anyway in the question, that sodium carbonate was used to standardize HCl, which is what the question tells us. And we then use that HCl to standardize sodium hydroxide. In part A, we were given information to prove that the concentration of the HCl was 3.76 times 10 to the power minus 6 moles per liter. And this is the information we were given to prove that. We did that in part A. If you haven't watched part A of this video, you want to go back and watch that one. Now, so we know that we use this to standardize that. And this one had a concentration of 3.76 times 10 to the power minus 6. And 20, according to this question, 21.3 milliliters of this was required to completely neutralize 25 milliliters of this. And obviously, this is done using a suitable indicator, assuming that you know that part. Now, this is how this would look graphically. Imagine you had a conical flask. This conical flask, in the conical flask, you put 25 mils of sodium hydroxide. How do I know that the sodium hydroxide is in the conical flask? Because these are aliquots, and aliquots go in the conical flask all the time. Now, and you started delivering HCl into this conical flask. And the HCl we were using has a concentration of 3.76, and the volume that was delivered to get to the end point of this titration procedure was 21.3. Now that we know this, we've got a clear idea of what this question is all about. How do we figure out the concentration of sodium hydroxide according to the question? Just as a quick rundown, what you would do is you would find the moles of acid using this data here, which is concentration times volume. Once we know the concentration of HCl, we know the moles of HCl, we can then use a balanced equation to figure out the moles of sodium hydroxide here. We can use a balanced equation to figure out the moles of sodium hydroxide. Once we know the moles of sodium hydroxide using concentration is equal to moles over volume, we can then determine the concentration of sodium hydroxide. So these are the steps. Step number 1, Step number 2, using a balanced equation, and step number 3, where we just use this formula to determine the concentration of sodium hydroxide. So let's jump straight into it and do the carry out the relevant calculations. So from here, the first step, we said we need to figure out the moles of HCl, which is equal to concentration times volume. And then to do that, we say it's 21.3 milliliters. The 21.3, it's in milliliters, and our concentration is in moles per liter, so our units must be the same. So the volume part of our units must be the same. So we need to change this 21.3 milliliters to liters, and we divide that by 1,000. If you divide 21.3 by 1,000, you get 0.0213. So that's 2.13 times 10 to the power minus 2 times 3.76 times 10 to the power of minus 6. Now, if we multiply these two numbers, we get 8.01 times 10 to the power of minus 8. These are the moles of HCl that reacted with the 25 mils of sodium hydroxide. Now, if we write a balanced equation, because we want to look at the ratio at which HCl and hydrochloric acid were reacting. So if I say HCl plus sodium hydroxide, what do I get? We get sodium chloride plus water. If we check, let's just quickly check this equation is balanced. If we do a quick rundown, and because we've got 1, 1, 1, everything is 1. So in this case, the ratio of HCl to sodium hydroxide is 1 to 1. I can therefore say moles of HCl is equal to the moles of what? Sodium hydroxide, which is equal to 8.01 times 10 to the power minus 8. Once I've done this, I now know the moles of sodium hydroxide. To find the concentration of sodium hydroxide, what do? I go on and say moles divided by volume, which is equal to 8.01 times 10 to the power minus 8 divided by my volume. Once again is in milliliters. I need to change that to liters. These are the little piranhas, little things that nibble into your marks if you're not careful. I can't stress how many times I've seen students forgetting to change that volume to liters. So here we can now say 2.5 times 10 to the power minus 3. I prefer scientific notation. Some students would like, why don't you just write 0.025? Because at the end of the day, with significant figures, it's easier to identify significant figures if you write your answers in scientific notation. That's one of the applications of scientific notation. When you're dealing with significant figures, it makes life a lot easier, because any zeros that you take out and you write them as to the power of it means they are not significant. So these 3 zeros are, times 10 to the power minus 2, not minus 3, sorry. These 2 zeros I've taken out are not significant. I've got 2 significant figures in this value. Anyway, let's move on, because significant figures, it's an important thing that SCASA specifies, where, because they say one of the things you should be able to do is to give your answers to the appropriate number of significant figures. They are not saying to 3 significant figures. Be mindful, because I always see most students, especially because in physics, right at the front of the paper, most of the time they say express your answer to these many significant figures, and they give you what they want you to express your answers to. In chemistry, they don't give you. You have to know how to decide that, and there are rules that we learned in year 11. When you multiply or divide, you use the least number of significant figures in the data that you are using. When you are adding, you use the least number of decimal places to represent your data. So those are the 2 rules you need to remember to be able to do that. Now, let's move on. So if I divide these 2 numbers, I'm going to get 3.20 times 10 to the power minus 6 moles per liter. Right. That's the molarity of sodium hydroxide. Just one more thing before I wrap up this video. You find that, SCASA, when they send out their examiner's report, they are always stressing that students must show their reasoning in their working out. I know some of these things we take them for granted. This part here, I'll repeat again, is the chemistry. That's what SCASA is looking for, because you are studying chemistry and not mathematics. We are just applying or using mathematics to solve chemistry problems. This part of substituting and writing answers, etc., yes, it's important, but you need to show SCASA where you are applying the chemistry concepts. This is part of the reasoning. How did I get to the conclusion that the moles of sodium hydroxide are equal to the moles of what? Of hydrochloric acid, because I used a balanced equation. That's a chemistry concept. Here's another chemistry concept. So at the end of the day, if you make a mistake on this one, let's say you get 4.2 for some reason, but you are supposed to use this answer in your next procedure. And we follow this and we realize that you are applying the chemistry concepts correctly. It was just unfortunate that your calculator let you down, or you punched in wrong numbers, or something happened along the way because of being under pressure in the exam. We will still give you full marks for the next section using your wrong answer, as long we can see that chemistry concepts have been applied correctly here. So display your working out, show your reasoning, make sure you are very clear, write neatly. That's another issue as well, which I've made a video about in terms of handwriting. So I'm going to love you and leave you, and I shall see you when you attempt the next video. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.